Hey, it's Mr. Harper Smith here. Today we're going to be talking about how rate of change relates to a new topic called slope. Alright? There's two things I need you to do before we get started with it all. First, I need you to copy down everything that you're seeing here on the board. This rate of change table and this graph. The tick marks on the graph come up to 12 on our y values, and on our x values they come over to 10. Once you have that first thing done, copying that down, the second thing I need you to do real quick is fill out the rate of change table. Okay. Also, figure out what the constant rate of change is. There is a constant rate of change on this one. Alright, pause the video, resume the video when you are ready to continue. Alright, you should be ready to go now. So, what we're going to do is we're going to figure out the rate of change of what's happening here with these hot dogs. Somebody's obviously very hungry. Somebody's eating 3 hot dogs in 2 minutes, 6 hot dogs in 4 minutes, 9 hot dogs in 6 minutes. They're hungry. I don't know if I could even eat 6 hot dogs, to be honest. So, let's figure out what the rate of change is. The change in my y values is what I normally do first. My y values, it looks like they're going up by 3, and they go up by 3 again. And they go up by 3 again. I just keep adding 3 every single time, kind of like what we did in the last couple days. Now this plus 3, do I put it on top or on the bottom? On the top. Alright, that is the rate of change for my y values. Let's look at the rate of change for my x values. It looks like they're going up by 2. 4 to 6, I think that's also going up by 2. 6 to 8, I need to add 2 again, plus 2. So my rate of change is 3 over 2. You don't have to put the plus signs. You only have to put them if they are negatives. But I will never mark you wrong if you put a plus sign on it. Okay, let's see how this now relates to slope. With slope is the same thing as rate of change. Except slope is visual. This is a very visual way to see rate of change. We can see this line is going up at a constant rate, or at least what appears to be a constant rate. It appears to be straight, despite my imperfect drawing skills. So, let's start with the same variable as we did over here, our y values. We need to look at what are my y values going up by every time. So from this point to this point, what is the change in my y values? The y values here are 3, and the y value here is 6. To go from 3 to 6, what do I have to add? 3. Let's do the same thing here. To go from 6 to 9, what do I need to add? To go from 6 to 9, I need to add 3. One more time. 6 to 9. Sorry, 9 to 12. I need to add 3. Every single time I'm going up by 3. Does that show a constant rate of change? Absolutely. Alright, now let's do the x values. So the x values are the change here. These are my x-axis. So we've got 2, we've got 4. I'm going to add 2 to go from 2 to 4. From 4 to 4 to 6, I have to add 2 again. From 6 to 8, I have to add 2 one more time. Alright, now here this is where we're going to see an even bigger connection. Rate of change is written the same way as slope. The y values, the change in y values go on top. The change in x values go on the bottom. That's your slope. This is why we've usually been leaving it as a fraction, because over here, that is what slope is. You normally leave it as a fraction. Alright, down below there are 2 quick practice problems. I want you to try to take what you've learned here and figure out the slope for the 2 pictures, the 2 graphs that you're about to see. Once you've done that, there's another video to continue where we're going to go a little bit more in depth into what slope is.